Welcome back, grade 11 and 12. We are still doing theorems. We are doing theorem 6 now. Remember, we have dealt with theorem 1 up to 5. So each theorem borrows to another. So in order for us to prove theorem 6, we have to take something from theorem 5, maybe 4 or 3 or 2 or 1. So all these theorems, they are intertwined. So here we are going to prove theorem 6. Theorem 6 says an exterior angle of a cyclic quadrilateral is equal to interior opposite angle, which is exterior angle of a cyclic quad. We are given that A, B, C, and D are points that lie on the circumferences of the second. A, B, C, and D, they lie on the circumference of the second. Circumference means where the end of the second, not inside the second. Right, we are required to prove that angle C1 is equals to A. Here is your C1 is equals to A. Now to prove that, we start by statement and reason. Please, Bantonabam, please, grade 11 and 12, whenever you are doing the including geometry, the cyclic geometry, please make sure that you write the statement, separate it to the reason. Maybe this is the style, the format which I like. Other teachers will teach you that you don't just do anything, just write a statement and a reason. But without a statement and a reason, you are doing nothing in cyclic geometry. Right, you start. You look at your given statement. Now you start by saying, you see, this angle here, C2, is equal to angle A. You see what I'm saying? Which is C2 plus A are all equals to 180 degrees. Is the previous theorem 5 that says that the opposite interior angles are supplementary. So we are supplementing A and C2. You start by saying angle A plus angle C2. Angle A plus C2 is equal to 180 degrees. The reason for that is opposite angles of cyclic quadrilateral. The opposite angle of cyclic quadrilateral supplement. The opposite angle of cyclic quadrilaterals supplement, which is A plus C2. They give you 180 degrees. If you can check in this thing, you have the situation whereby C2 plus C1 is equals to 180 degrees. You see, C2 plus C1 is 180 degrees. The reason for that is a what? It's a straight angle. Straight line sum up to 180 degrees. 180 degrees. Now we say A plus C2 is equals to C2 plus C1. The reason for that, they both equals to 180 degrees. Now that they both equals to 180, we can equate them. So when we equate them, that means they must be equal. Now, you can say C2 is equals to C2, which is common. Therefore, angle A is equals to angle C1. Then you come and check your drawing here. That means that this angle is equals to A. Angle C2 is equals to C2 because you find C2 in this combination and you find C2 in that combination, which is common. Therefore, what is left? In other words, this one is going to cancel that. Then you are left with A is equals to C1. This is the statement we have proven. Then the required to prove says you must prove that C1 is equals to A. This is it. Now, grade 11 and 12, please go and practice. This is all for you. I want you to practice this. Practice until you find a place where you are given a problem to apply these theorems to prove yourself that now you are fit for a geometry. Thank you very much. I like to see you practicing this. Then you are set for your exam. Uncle Pythagoras signing out. Please do not forget to like and subscribe and share the videos for others to get a plug. And please do not forget to watch the whole video. Make sure that you don't skip the advertisement so that you will come to the end of the video. Thank you very much. Without any break, I will see you in the next videos.